begin with text normalization first. And what text normalization really means is that it is the process of transforming a text into a canonical standard form. So it will convert all the text into a standard form. For example, the word good and good can be transformed to the word good, its canonical form. Another example is mapping of near identical words such as stop words. So stop words are something we'll have to remove in our text. And then what we do over here is we split the text wherever there's a new line with the help of this code. So text dot split slash n will separate the text wherever a new line is present. And after that, we separate the text wherever there's a tab space. So we do it with the help of slash t. So slash n stands for new line and slash t is a tab. So we have separated our text from with the help of slash n and slash t over here. And then this piece of code here, what it really does is that it allows only characters from A to Z and capital A to Z, excluding other characters. And then coming to tokenization. So let us see what tokenization really is. So tokenization is the process by which big quantity of text is divided into smaller parts called tokens. So we basically split our text into words, which are called as tokens. And over here we have natural language processing, which is used for building applications such as text classification and chatbots, and sentiment analysis. So we basically convert the text into smaller tokens. Over here, what we have done is that we have converted all our characters into lowercase with the help of dot lower. And what this will do is it will convert all the characters in our text into lowercase. And over here, we have tokenized them. We have tokenized the sentence with the help of sentence tokenization. So I've saved all the lower letter characters in the letters only, and I've sentence tokenized these letters only, and this is our sentence tokenized text. And then what we have done is I have removed all the alphanumeric characters. So we'll have to remove all the special characters present in our text. Once we have done the sentence tokenization, there might be a few places where there are special characters, and such characters have been removed. And over here, this function over here shows us that all numerics are represented with x over here. And if we have a decimal value, then it will be represented by triple x over here. And so we have replaced all the numeric values with these values. And then we have created another clean NDA. And what we really do over here is that we have taken all the tokenizations and we have mapped them. And this will remove all the special characters in the end. And all the alphanumeric characters and other such decimal values have been replaced now. We have replaced them with characters like XXAA. And after that is done, we remove contractions. It's not actually removing contraction, it is expanding contractions. So contractions are words like isn't, didn't. As you can see over here, these words get converted into is not, they get converted into their full form. So over here, there are converted to they are. So it is basically expanding contractions, and we do that with the help of contraction map. So we have taken the corpus NDA over here. We have saved our text before in corpus NDA, and this holds our text. So we have taken this corpus NDA and we have done the expanding contractions. And after that, we have word tokenized our corpus NDA. And again, we have, as you can see over here, dot lower changes it into lowercase. And once that is done, all the words are converted to tokens and contractions have been expanded. And at the same time, we have also converted our letters to lowercase. And this is the resulting text. And over here, we need to save this text into a data frame. So what we do is we split it by space tab. we remove the tab spaces and new lines, and in the end we have this data. This is our resulting data which has to be further cleaned, and we take this data and save it into a data frame, and this is how our data frame looks like. And as you can see over here in this data frame, there are a few additional columns like 1 2 3 4 5 and 6. These columns are to be dropped, and we have dropped these columns, and this is the resulting data frame, and further processing has to be done on this data. Over here you can see that this column is called as 0. So what we did is that we have replaced the 0 with text using the rename function. We have just renamed this column from 0 to text, and this is the final data set that we are left with. Okay, and over here you can see that in this data frame there are a few rows like the 0. You can see that these are repeating twice, the 0 and 1, and in this column we also have these 999. This index is again having two texts that are repeating, so we need to drop this. So rows 0 1 and 1000 and 1001 have been dropped, and as you can see now we have our 1000 rows. So this is the correct data set now, and we need to remove additional characters present in this data set now. So I have used this code over here. So this code, what it really does is that wherever it finds digits, it will remove them, and commas and br and all such special characters have been removed, and some characters have been stripped. As you can see over, we used a string dot strip over here, and this way we have cleaned our text now. And then we come to the lemmatization